This packet, not packet, this table has everything you need to know and memorize for each point of concurrency. I need you to highlight the key information. There's pretty much the name, how it's formed by definition, and the special properties. So I need you to kind of get this down. These are the things you need to start memorizing. You need to start studying. You might want to make a flashcard for each one because you got to know it by heart. Yeah, like you'll say in center, what it's formed by, and definition, special property. Okay. On your sheet, you have the 4 special points of concurrency and the special segments that form them. Now, on the back, they give you an example of where that point of concurrency is. Now, I am not going to stress that you memorize if it's inside, if it's outside, for how it looks for each type of triangle. That's not the point, the main idea. But you are going to use these pictures to help you do some problem solving in your homework packet. And you're going to use the table at the front of the table to help you do some problem solving with the properties, okay? So there's an example of each, just so you know. We might need to add some things to this sheet, because if in center is formed by what special segment forms the in center? Angle bisector. So you probably need to add arcs to show that you have an angle bisector, okay? Because that's what you would have to see if you're identifying it, okay? Now, circumcenter. What type of special segment forms the circumcenter?
Perpendicular midpoint bisector.
So we need to see a box to show it's perpendicular, and we need tick marks to show it's going through the midpoint and it's bisecting. Where's what? Okay. Who forms the centroid? What special segment forms the centroid? The median. Okay, so to show that it's a median, it has to go through the midpoint to the opposite vertex. So all I need to see is tick marks to show that it's going through the midpoint. And what forms the orthocenter? Altitude. Okay, what is an altitude? It's a right angle. It's perpendicular. Okay, so it's a segment that is perpendicular, and it goes to the opposite vertex. So perpendicular to the side, to the opposite vertex. So all I need to see for an altitude are the right angles, symbols. Are we okay on that? So, because you're going to be asked to see, can you identify what it is? And we kind of worked on that yesterday in our homework packet. All right. So, you have your stuff highlighted. You have the markings. You can. All right. So this is the second worksheet. Now, using the table, using your own knowledge, okay, your own intellect, I want you to see if you can answer 23 through 25. Now, this is how it will be on an assessment, on a quiz or a test. You're going to have a picture. I'm not going to ask you to draw anything. It's already going to be given to you. You have to answer a question based on the diagram. So on the first one, they want to see, can you identify the median of the triangle ABC? If you're not sure what a median is, go back to your table, read the definition, and see which segment applies that definition. All right, the first one is for you to identify the median. I heard earlier it has to go from the midpoint to a side to the opposite vertex. So AD is correct. That is the median. Yes. It cannot, guys, stop talking, please. It cannot be FB because I don't know that F is a midpoint. There's no marking. Yes, there's no tick marks to show that F is a midpoint. So I can't pick that, okay? There's tick marks right here. Oh. Yeah, the tick marks are between CD and DB. All right. Identify. Stop playing. Identify the altitude of the triangle ABC. The altitude. You got B, as in this is your answer choice, B? Okay. And I heard an A. Okay, who can explain to me what an altitude is? Kosi. Vertex. You said vertex from a vertex and forms a perpendicular line. Okay, so GH. Does GH go to a vertex? No, so that's not going to work. Okay, the answer was A, CE. CE. 25. In the triangle. I heard an E. A D. Okay. All right, so guys, do y'all understand what this segment FB is? What is it? It's saying bisectors. Okay, so I know that this angle is 39. So 39 is over here as well. They want me to look or use this triangle. I'm just going to redraw it. So we have 78, and we're trying to find the angle BCE. So could you use the right triangle to help you find that? That's why the answer is E12. Okay? 78 plus 90. Or whenever you have a right triangle, you have a... Can y'all stop? Whenever you have a right triangle, you have a relationship, meaning you have two acute angles that remain in a right triangle always, and they're always complementary. They're always going to add up to 90. So if I know this is 78, all I got to do is subtract it from 90, and that gives me the other one. Okay? Or you can use a triangle sum theorem. All right. Now, we're going to use the diagram and the indicated measures to solve perpendicular bisector meeting at point D. So, my question to you, because this is a perpendicular bisector and it's meeting at that point, what is that point D called? What? No, it's not a centroid. Look at your table. Go to your table. In the table, we're looking at perpendicular bisectors, so it has to be what? Circumcenter. Okay, so we're staying in this column. I need you to go down to the bottom and read the special property with a circumcenter. Equal distance from what? Yep. To the vertices. Equal distance to the vertices. All right, so since this is the circumcenter, then the equal distance from the circumcenter to the vertices, so that means from D to A and D to C and D to B would all be the same distance. All right, so now I want you to answer 26 and 27 right now. There should be no math, no computation, mental awareness based on the property we just marked. AD, yes, is 11.5. All right, 26. Raise your hand if you have it. Kosi. Yep, it's 11.5. Give yourself a point for your team. Obi? Yes. It is also 11.5. Okay, on the celebration. Day 5, please, or day 4, sorry. Tally mark, yeah. All right. 28 and 29 is the same question, so we're going to omit that. Okay? All right, 30 was review in regards, it's a spiral question. We did it last 6 weeks. They are parallel. This is a mid-segment. Mid-segment meets at the midpoints of the side of a triangle. Okay. All right, Rahel, what'd you get? How'd you get that? So x is equal to 3x minus 10. Do they look the same? No, that's not reasonable. Okay. Yes, it would be 2x. Give yourself a point, Jordan. Okay. Mm-hmm. And the celebration for day 4. Uh-huh. Huh? The mid-segment is double the parallel side, or half the parallel side. Huh? Yeah, x equals 10. Who can give the equation for 31? Charles.
31, I got 4x plus 46 is equal to 11, to 8x.
All right, correct. Okay. You double the mid-segment equals to the parallel side. So what was x?
11.5.
Okay, 11.5. Or you could have gave me 23 over 2. Either way, I would accept it. Charles, give your group a point for celebration. Who can give me the equation for 32? Jessica. 10x minus 6 equals x plus 12. That is correct. And what did we get for x? 2. That is correct. Okay. Give yourself a point. Okay, on the back. On the back, they tell you what point of concurrency you're using in the diagram. It tells you that V is the centroid. Okay. So that is where that point V is your centroid. It also tells you that SU is perpendicular to RT. Then it says UT was 10, RW is the 6.25, SV is 5, and RS equals TS. So I'm just going to, just because this is given, this side is congruent to the other side, ST. Because we're talking about a centroid, you need to go on your table and read the property for a centroid. See if we can figure out what we're going to do with that property. It's what? All right, the centroid's location is 2/3 of what? Vertex to a side. All right, 2/3 from the vertex to a side, and it's 1/3. The one part. What else do we know about the centroid? We have 2-to-1 ratio. It is also the central of gravity. All right, 2-to-1 ratio. What is that 2-to-1 ratio for? 2/3, 1/3. There we go. We got the part. So we know which one is the big part, which one is the small part, correct? Okay, so we're going to use that property to help us problem solve because they want us to first find ST. And I have to use ST or figure out ST by understanding the centroid is formed by medians. So it's formed by medians. So see if you can come up with a plan. Stop. All right, what is ST? Yes, Jordan, how we get that? Mm-hmm. Yep. So, yep. So this is equal to ST. Yes, ST 12.5. Give yourself a point. Hold up. I got the question. Yes, Kosi.
Okay, so I got 5 equals 2/3 of x.
5.
You can multiply 5
Okay, so you got 5 is 2/3 of SU. Okay, do we know what SU is? No, so that's going to be our unknown. So 5 is 2/3 of x. So you asked if you're going to multiply. Are you trying to get rid of the fraction, Kosi? Okay, so if you're going to get rid of the fraction, you're going to multiply everything by the denominator. So that would be 3. Okay. So that it's going to give you 15 is equal to what? 2x. Okay. And then we're going to divide by 2. And so our median, or SU, is 7.5. Anyone see another way of doing this? Okay. This is 2 to 1, right? 2 to 1. So this segment here is half of the 5. So yes, you could make that 2.5. And then I'm trying to find the whole median. So just 5 plus the 2.5 gave you 7.5. Yeah, if you have one of the parts, yeah, you can. Okay. Then you will double it. If you have the 1/3 part, then you double it, and that'll give you the 2 to 1 ratio. Yeah, divide by 2. Yep. Okay. All right. So UV was the what? The 2. Yeah, the 1/3, which is the 2.5. 1/3 of the median. And do you have the perimeter? Hayden, what's the perimeter? Yep, the perimeter is 45. Questions on how to get the perimeter? Okay, we understand this type of problem? All right, you are responsible for the remainder of the worksheet. Okay, I'm going to give you time to work. Now, understand. Okay, so how do we find ST? How do we find ST? Pythagorean theorem. You have to see that this is the right triangle in here. I'm going to use this median and use that ratio 2 to 1. So if that's 6, this would have to be 3, which means the whole side is 9. And then this would be a squared plus b squared equals c squared. Okay. Yeah. I could say that if I knew the two sides were congruent. So this, no, it didn't. It didn't say that. It depends on the type of triangle, on that relationship. Okay. All right. So UV is 3. The perimeter we should have had 54. SU was 9. And then here we have perpendicular bisectors. So we have a circumcenter. So they meet at D. What is BD going to be? 12. And it should be 12, right? And this was 63. Okay? Round what up? Your homework that are going to be graded on Tuesday are on Edmodo. Okay, we are going to do some problems in class. And I did say if you do extra, I will give you extra points for your team and extra points on your score, individual score. So when I check for extra, it'll be tomorrow on Monday. Okay? Huh? The individual score is when you turn in your packet. Okay? Yeah. So on number 5, just make sure we understand the special segments. We're going to draw TU as an altitude, median, and perpendicular bisector of the triangle UVW. So an altitude, what makes an altitude special? What is it going to do? Okay, perpendicular, 90 degrees from a side to a vertex. What's a median? What makes it special? Vertex to what? To a midpoint. Okay? Yeah, you can look at it that way, yeah. Because it's going to be perpendicular and it's going to use the midpoint. Okay? Now, it will be both in special cases, Kosi, because sometimes you can draw that perpendicular bisector and it doesn't necessarily go to a vertex. So it just depends on the triangle. But in this one, we do want it to be that way. Okay? So we're going to draw a triangle and we're going to create, oh, that's horrible. We're going to create our altitude, median, and perpendicular bisector all in one. So guess where you think you're going to have to put it? This is you, right? You're going to have to go from the top, straight down, put our box. add our tick marks. This little point here is going to have to be T. Then I'm just going to add my V and my W. And now I can see that it is an altitude, it is a median, it is also a perpendicular bisector, all in one. Okay? Now, use to help you with always, sometimes, never. If you look at your points of concurrency and look at your pictures, this will help you identify if it could happen or not. So, look at your pictures on your examples on your points of concurrency. Here, again, 3 altitudes. So go to your altitude column. What point of concurrency deals with altitudes? Orthocenter. So look at your orthocenter column. Can you have 3 altitudes in a triangle intersect at a vertex of a triangle? Can your orthocenter be on a vertex of a triangle? Yes, yes. It can happen on the right triangle. So this is sometimes. If you looked at your picture correctly, you saw it intersect on the right angle. All right, so 3 medians. Okay, what point of concurrency deals with 3 medians? Centroid. So look at your centroid column. It says 3 medians of a triangle intersect at a point outside the triangle. Can that happen? Does your centroid ever happen outside? No. So this would be never. It's always inside. Okay. Last one. 3 angle bisectors of a triangle intersect at a point inside the triangle. Yep, that one is always. What point of concurrency is dealing with the angle bisector? The incenter. Good job. All right. Next page. Do I want to do this page? What do I want to talk about? All right, we're going to look at the true or false. So, use the picture to the right to determine true or false. It says if G is the midpoint, so if this happens, if it's the midpoint of ED, then CG, C to G, is the median of EBD, of that triangle. Is that a median? No, that's false. Yeah, median has to go to a vertex. So it goes from the midpoint to a vertex. All right. It says if CF is perpendicular to ED, so if CF was perpendicular to ED, I'm going to put my box, then CF is an altitude to both ECD and ECG. Is it an altitude? That is true. It's an altitude to both. Altitude goes to a vertex and perpendicular to its opposite side. All right. Vertex and perpendicular. A segment from the vertex to the opposite side and it's perpendicular. Now, 12. If EB is perpendicular to BD, then EB is an altitude to the triangle ECD. Can the altitude be outside the triangle? Yes, it can. This is true. You can have, because if I extend this side, okay, it's going up to that vertex, okay. An altitude can be outside the triangle, and it happens when you have an obtuse triangle, okay. All right, it says if CF is perpendicular to ED, CF is perpendicular to ED. CF is a perpendicular bisector of ECD. False. That is false. It's not bisecting. It doesn't say it went through the midpoint. It just said it's perpendicular. Okay? If CG is a median of ECD, if it's a median of ECD, then G is the midpoint. Yep, it's true. For it to be a median, it has to go through the midpoint. And then the last two, each leg of a right triangle is also an altitude of the triangle. That is true. Okay? That is true. All right, so now they're going to ask you, can you name the segment using the figure? So there's only one answer to number 16. FD, no, it's not an altitude. Here's FD. It goes here to here. Look at these numbers. So what is D? It's a midpoint, so it's a median. FC. It's just 4 answers. Angle bisector. It's an altitude. It's a median. It's all 4. Perpendicular bisector. Okay. FC. 4 triangle BFE. If I'm looking at just the triangle BFE. BFE. What is FC going to be? It is an altitude. Okay, all right. I just abbreviated. So, you have problems that you need to start doing in your packet. They're on Edmodo. You have an exit ticket before you leave. You may use your notes. I would use the table